In an isosceles triangle, two sides of the triangle are congruent. The two congruent sides in an isosceles triangle are called the legs of the triangle, and the one non-congruent side is called the base. The two angles on the base are called the base angles, and the one angle that is not a base angle is called the vertex angle. The base angles theorem says this: if we have an isosceles triangle, if two sides are congruent, then the two angles opposite those two congruent sides are also congruent. In other words, the base angles in an isosceles triangle are congruent. Theorem 4.9 is the converse of Theorem 4.8. It says if a triangle has two congruent angles, then the two sides opposite those two congruent angles are also congruent. Let's use the base angle theorem. If we look at this triangle, we have two congruent sides, and the two angles opposite those two congruent sides are going to have to be congruent, which means that these two angles are the same, which means that x is 35 degrees. To solve for y, we need to use the fact that a triangle has 180 degrees. And we need to take 180 and subtract 35 degrees and subtract 35 degrees. 35 degrees for this angle and 35 degrees for this angle. A grand total of 110 degrees. We can check this answer by taking 35 plus 35 plus 110 and getting 180 degrees. In example 2, across from our two congruent sides are two congruent angles. If we look, we've already used 35 degrees for this vertex angle. So if I take 180 degrees, because there's 180 degrees in this entire triangle, and subtract off the 35 degrees I've already used, I have 145 degrees left. And since both of these angles are exactly the same, I'm going to divide up this 145 degrees equally. I'm going to divide 145 by 2. That tells me that each angle, x and y, will be 72.5 degrees. I can check my answer by taking 35 plus 72.5 plus 72.5 and making sure that I get a grand total of 180 degrees in this triangle. In a right triangle, there is one right angle. The side opposite that right angle is called the hypotenuse, the hypotenuse. And the two other sides that aren't the hypotenuse in a right triangle are called the legs. Now the hypotenuse leg congruence theorem says this: if we have two right triangles, and between those two right triangles, the hypotenuses are congruent, and one of the legs is congruent, that's enough to prove that my triangles are congruent. And after my triangles are proved congruent, all the remaining parts will also be congruent. So the hypotenuse leg, the HL theorem, gives me another way to prove triangles congruent. Let's look at some examples. If we look at these two triangles, they have a shared side in common, and they also have right angles. And across from the right angles are the hypotenuses and legs. So these two triangles are congruent to each other by HL. Now be careful, just because two triangles have a right angle does not mean that it is automatically HL. If we look at this example, we still have our shared side, but this time we have a pair of congruent angles that are right, a pair of acute angles, and a pair of congruent sides. So these triangles are congruent by angle, angle, side, angle, angle, side. Looking at example 3, we have two congruent right angles. But if we look at what else we have congruent, we have a pair of congruent legs and a pair of congruent legs. In fact, the hypotenuses we know nothing about. So how are these triangles congruent to each other? We have a pair of congruent sides, another pair of congruent sides, and the angles between those two pairs of congruent sides. So these triangles are congruent by side, angle, side. Slightly different is example number 4. We still have our congruent right angles, but this time the hypotenuses are congruent to each other, and we have a pair of congruent legs. So these two triangles are congruent to each other by HL. And the last two examples. Since this is a right angle, this angle has to be a right angle. And we have a pair of shared sides, but we know nothing about the hypotenuses in this example. So if we look, we have angle, angle, side. So these two triangles are congruent to each other by angle, angle, side. If we look at the last example, if this is a right angle, this has to be a right angle. We have a shared side between the two triangles, and this time we do know that the hypotenuses are congruent, and we have a pair of congruent legs. So these two triangles are congruent by HL.